All right, so for homework B, we already did question 1, and then we'll be doing part 2 for using the linear algebra ranking to find the number of dimensionless groups. So we can start by importing numpy as np. And then we'll write our matrices for the variables listed that we found in the previous part of the video. I'm going to start by typing all of these out. B. Okay. And then I'm going to pull up these solutions from last time. So for the pressure, we found that we got 1, -1, and -2. 1, -3, and 0. 1, -1, -1. 0, 1, 0. Oh. And then 0, 1, -1. All right, so then we're gonna do dim matrix, and then it's equal to the variables that we just typed out, but with the np.c underscore bracket, I think, and then p rho mu l d b. Oh. And then we have to add the dot as type float. Oh. And then we do dim underscore matrix to have it show what we found. And then we'll do the np dot linear algebra underscore rank that we've been given here. And that's gonna be p rho mu l d b. And I think that's it. Oh, maybe not. Oh, we don't type this again. We just do, oops, parentheses, dim matrix, I think. I'm forgetting something. Oh. Okay, there we go. All right, so that's all for question 2, and then moving down to question 3, with L, rho, and V as the core values and D, mu, and P as the non-core, we'll be using the linear algebra solve to determine the powers of the core values in each of the dimensionless groups. So that's going to be our the solve function. That's the np dot linear algebra underscore solve, and we're going to do that for all 3 of our variables that are in the non-core groups as negative, so that'll be np.c underscore, what did I just say? I don't remember if it's brackets or row v. Dot as type float, I think, and then you do a comma and it's negative dot c underscore, maybe it's brackets here. No, I think this one's d dot as type dot float. I think that's right. Oh. What am I forgetting? Oh, maybe I tried these as brackets. I think I... And then something else doesn't look right. Oh, this one's not .c again. It's array, I think. Let's see. Okay, there we go. Yep. And then I'm actually just gonna copy this and then plug in for mu, because it's the same system, or the same setup. And then again, plugging this in for p. And those are going to be our, I'm gonna switch over to my iPad instead to write out the actual dimensionless groups with the variables in the right place. All right. Continuing homework 4, part B, question 3, we're writing out the dimensionless groups from the matrices that we found. And I already went ahead and wrote what we found in our work here. So, to write out the dimensionless groups, it's essentially going to be this, each variable, times this that we found as it relates to this. So I guess you could say the non-core times the core, using the number of this. Yeah. Okay, so that's going to be times L to the negative first for this one, or D over L. Now for the next one, these are all negative 1, so you're just going to do P negative, or rho negative 1, L negative 1, and V negative 1. And then that's going to be mu over rho L V. And then the last one is going to be the rho negative 1, no L, and then V negative 2, which is equal to P over rho V squared. So these are going to be our 3 dimensionless groups. And then moving on to question 4, we're just gonna, which again, I already wrote those here just to make it a bit shorter. So we know that the Reynolds number is this here, and what we're gonna do is multiply, we're gonna manipulate these equations to end up in this form of some sort. So how we're going to do that is doing this second equation, so using 2, we're going to do that times the inverse of 1, well, of 1 here, and this is actually going to end up canceling, so then we're left with the inverse of our Reynolds number. So we can just flop these, and then we're left with, or multiply it, I guess, if you want to do to the negative first power. That makes it our rho v d over mu, which is equal to the Reynolds number. So there's that for number 4. And then number 5, we're going to be writing the Bernoulli's equation for the horizontal pipe of constant D and frictional heating in terms of the fanning friction factor. So we're going to do this to correspond to a relationship between the 3 dimensionless groups that we've derived. So starting by writing what we know as Bernoulli's equation for this setup is going to be equal to the frictionless heating, but then expressed in terms of the fanning friction factor, which we know as 4 times the friction factor times the L over D times our V squared over 2. So to get rid of this and put it in terms of, F we know is equal to 16 over the Reynolds number. So we're gonna plug this back into here. And that's gonna look like this. So 4 times 16 divided by 2, or 16 times 2, is equal to 32 over RE times our L over D times our V squared over 2. And then from here, oh no, not over 2, I already included that, so times V squared, sorry. So from here, we're going to replace again, the Reynolds number with what we know from, I guess I could have written it here, rho v d over mu. So we're going to plug that in, and we're going to get change of pressure over mu is equal to 32 times rho v, no, it's divided, so I'm just going to go ahead and flop these to make that come to the top. That's going to be mu over rho v d times our L over d times our V squared. From here, we're going to divide both sides by this V squared, and that's going to give us the change in pressure over that is equal to 32 V squared over rho v d times L over d. And then here we can actually label the, we have all 3 of these present, so I'm going to label them by the numbers. This is the inverse of a dimensionless group 1, same here, and then this is the negative form of the 3rd dimensionless group. So that's going to be our final answer, and that is all for part B.